In the next example, we have a box containing 3 index cards, 2 of which have the word success written on them, and 1 of which has the word failure written on it. A second box also contains 3 index cards, but in this box, 1 of them is labeled success and 2 of them are labeled failure. You perform an experiment with 2 trials. In the first trial, you draw a card from the first box, and in the second trial, you draw a card from the second box. The random variable x records the total number of success cards in the 2 trials. Is this a binomial probability experiment? In other words, we have these 2 boxes. One of which has three cards, and in this first box, 2 of the cards are labeled success, and 1 card is labeled failure. Then we have a second box in which 1 card is labeled success, and 2 cards are labeled failure. Now, in trial 1, we take out a card, and we record whether that says success or failure. And then in trial 2, we take a card out of the second box and notice whether it says success or failure. And our random variable x records the total number of success cards, so 0, 1, or 2. Is this a binomial probability experiment? Well, let's see. The number of trials is 2, so that's clearly a fixed specific number of trials. They are independent because the card drawn from box 1 does not affect what we get from box 2. The outcomes for each trial are success or failure. So that's certainly 2 mutually exclusive outcomes. But what about the probability of success in each trial? Well, in trial 1, the probability of success, there's 2 success cards out of 3, so the probability is 2/3. But in trial 2, the probability of success is different, right? Because when we're drawing from box 2, there's only 1 success card and 2 failure cards. So the probability of success in trial 2 is only 1/3. So my point is, P is not the same in each trial. So this is not a binomial probability experiment.